The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 3 different classes that may be observing this session. Therefore, when you participate in this, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. So this morning we're going to be looking at some questions left over from yesterday, section 10.4 part 1. And then when we're done with that, we will go ahead and take a look at part 2 and wrap up this chapter. Then tomorrow, there are no classes. It's Veterans Day. Thursday, we'll have a Zoom meeting and review. And then Friday, there'll be no Zoom meeting, but you will take your test. All right, so having said all of that, I want to do a review of some things. One of the forms of equations that we're looking at in this chapter, in fact, the main one from yesterday, is this. Y, oops, let's try that again. Y equals A times the quantity X minus H squared plus K. The axis of symmetry is at X equals H, and it's an equation. The vertex is at HK. It's an ordered pair. If A is positive, the graph opens up. If A is negative, the graph opens downward. Okay. Now, taking that information into account, we have the following function. F of X, and this is, let's see, what is it? This is number 16 from 10.4, part 1. Okay, F of X equals -6 times the quantity X plus 3 squared plus 4. So looking at this function, A is -6, H is -3, and K is 4. So the vertex is at -3, 4, and the axis of symmetry is at X equals -3. So now let's take a look at the WebAssign actual picture. So we see this problem here. So the vertex is at -3, 4. It's an ordered pair. The axis of symmetry is at X equals -3. So down here on the graph, -3, 4 would be this point right there. So you'd enter that point. Here's your axis of symmetry. Now, you'd need to find a second point. So what we could do, let's go back to the other screen. And let's see, we know the vertex is at -3, 4. So what I'm going to do, let's see here. Let's make a table over here. I'm going to choose an X value that's right close to -3. So maybe -2 or -4. I'll go ahead and put -2 in there. So let's see here. So this is going to go right there. Okay. So F of -2 is -6 times the quantity -2 plus 3 squared plus 4. Order of operations, you would start inside. So you'd get -6 times, let's see, -2 plus 3 is 1. And then you do the exponent. So you'd get -6 times 1 plus 4. And that's -6 plus 4, which is -2. Sorry, I kind of got crowded there. Okay. So that tells us, let's go going back to our other screen, the WebAssign screen. Not only is our vertex at -3, 4, but we have another point at -2, -2. So again, what you'd need to do to graph it, you'd come over here to the left, and we can't see them, but one of these, I think it's this one here, is a parabola. Click on it till it turns solid blue. And then you must plot the vertex first, click on that, and then click on the other ordered pair that you found, and your graph should appear. All right. Any questions on that problem before we go on? Okay. So now, let's see here. We're going to go to, okay, 65, and here, and here. Okay. All right. So now we're going to take a look at problem number 8. And we have 3 functions that we're supposed to graph. Now, if you look at it, the graphs that are in black are the ones that the student entered. The graphs that are in green, I believe, are the correct answers. So let's see what we've got here. We've got f of x equals 1/6 x squared. We've got g of x equals 1/6 x squared plus 2, and s of x equals 1/6 x squared minus 6. So let's go back here. Oh, and this is problem number 8 from 10.4 part 1. Okay, so taking a look at the first function, the vertex is going to be at 0, 0, because it's in the form y equals ax squared. So there's no shifting that's happening. All right, now we need an additional point. Let's see, if x is 1, we would have, see, f of 1 would be 1/6 times 1 squared, which is 1/6. Okay, so our first graph would be, the vertex would be at 0, 0, and another point at 1, 1/6. So the vertex is at 0, 0. Okay, and the other point is at 1, 1/6. Now, this black graph, I have a feeling that it is correct. It's over the top of the green one. The problem is in graphing 1/6. How would you do that? So again, you'd come over here. Let's just assume this whole screen is cleared off. Okay, and you would graph. You'd push on the blue button until it turns blue. Okay, you'd plot the vertex here, and then you'd go over here to 1, 1/6, and you'd click on it. Now, it might not be exactly at 1/6. So once you've done that, if you come over here, you can graph on the vertical parabola, and I know it's hard to see, it's kind of faint, but you've got a point, 0, 0, and then 0.2, 1, 1/6. So if it, in other words, when you plot your points over here, if they don't end up where they're supposed to, you can adjust them by putting the values in here. But again, the most critical thing is you've got to do the vertex first. Okay, all right. So it looks to me like the first graph is correct. Okay, now let's go back to this other screen. What is this going to look like? Well, it's going to look exactly like this, but it's going to be shifted up 2 units. What is this one going to look like? It's going to look exactly like that, but shifted down 6 units. So down -6. So back to the graph. Okay. My vertex was at 0, 0, and I had the point 1, 1/6. Okay. So this second one that moves up 2, I'm going to take this point. So I'm going to go back here and click on this thing to start my second parabola. I'm going to come over here. I'm not going to click on this point, but I'm going to go up 2, and click it. From here, I'm going to go up 2 and click it. Okay, and that should give me my second graph. And what about this third one? It's going to be down 6. So back to the original 0, 0. It's going to go down 6, click it. From here, down 6 and click it. So basically what I'm saying is you don't have to completely start over each time. Going back to this, here you're going to move it up 2, here you're going to move it down 6. So once you've established where that graph is, you just create the new graph by moving everything up 2 units, and then the other new graph by moving everything down 6 units from that original. Okay. Now we're going to take a look at problem number 15. And let's see here what's going on with that. Okay. So this is number 15. And it looks like they've got the vertex correct and the axis of symmetry correct. So what happened? Okay. So the vertex is at 4, 0, and then it looks like the second ordered pair is what went wrong here. So let's see, if we've got f of x equals negative the quantity x minus 4 squared, and we know the vertex is at 4, 0. Okay, and we need to find another ordered pair. So again, from the vertex, I want to stay close by, so how about 5? So f of 5 is going to be negative, the negative is outside, 5 minus 4 squared. The negative is outside, 5 minus 4 is 1, 1 squared, so negative 1. So it's going to be at 5, negative 1. So if we go back here, we can see the green graph. We've got the vertex and then 5, negative 1, and then that would give you the correct graph. All right, any questions on that before I go on to number 17? Okay. And let's see here. Looks like we've got the same issue where the vertex and axis of symmetry they got correct. Vertex they graphed correctly, but that second point was the issue. So let's take a look here. We've got f of x equals 1/6 times the quantity x plus 1 squared minus 3. We know that the vertex is at negative 1, negative 3. So as far as the table goes, I would probably just use a point that's, right next to it. So how about 0? So let's see, f of 0 is 1/6 times 0 plus 1 quantity squared minus 3, which is 1/6 times 1 squared minus 3, which is 1/6 times 1 minus 3, which is 1/6 minus 3. Now here's where things get a little tricky. So 1/6 minus 3 is like 1/6 minus 3 over 1. The common denominator here is a 6. So I need to multiply 3 by 6 over 6. So now I get 1/6 minus 18/6, okay, which is negative 17/6. So what I'm going to do, back on my graph, I'm going to again start my graph. I'm going to plot the vertex at negative 1, negative 3. Now let's see, negative 17/6 is almost negative 3. So I might come over here and plot negative 3, or at least a little bit above it. Okay. Then I'm going to go over here and I'm going to change my second ordered pair. I've got negative 1, negative 3 here. And then my second ordered pair would be 0. And then here, negative 17/6. Okay. Now, This student used X as 1. We could have used X as 1, but when X is 1, Y is not 2 and whatever 7/3 there. So the calculation is what the problem was. Okay. And finally, 18. Let's see here what's going on with that. 18. The height in feet of the water level of a reservoir over a 1-year period is modeled by the function, let's see, h of t equals 2.9 times t minus 6, the quantity squared, plus 14, where t equals 1 represents January, t equals 2 represents February, and so on. How low did the water level get that year? Let's see here. Period. T is 1. Okay. So if the height, the graph represents the height of the water, right? Okay. Since A, where's my mouse at? Since A is a positive number, we're going to get a graph that opens upward. Okay. So the water level, the lowest water level would be at the bottom of that parabola. In other words, at the vertex. Okay. Let me switch to the other screen here for a moment and see if I can show you what I'm talking about here. Okay, let's say we've got this. All right, so right here, I'm just making a rough sketch of that graph. It's not totally accurate, but it's similar. Okay, so this axis is T. That's time in months of the calendar. This axis is H. It's the height. It says, how low did the water level get that year? So the vertex would be the lowest height of the water level. Do you see that? So basically we're looking for the vertex. Okay, now, where is the vertex? The vertex would be at 6:14. Okay, because there's H and there's K. It's back to the questions. It says, how low did the water level get that year? Well, the height would be 14 feet. Okay. When did that happen? The 6th month. So that would be June. Does that make sense? So basically, the vertex leads to the answers to these two questions. The lowest height would be 14 feet. And when would that happen? The 6th month, June. Okay, well, that's all the questions that people had. So now we are going to go on to 10.4, part 2. We've looked at equations in the form y equals a times x minus h squared plus k. And at the beginning of this video here a few minutes ago, I reviewed all of that. Now we're going to look at a different form, y equals ax squared plus bx plus c. Okay, this is also a form of a quadratic or second degree equation. In fact, that's the form you needed in set equal to 0 when you're going to use the quadratic formula. All right. When the equation is in this form, we don't use h and k. What we use is this. The axis of symmetry is at x equals negative b over 2a. All right. Using this a and this b. And then the vertex is at, keep in mind the x value of the vertex is always the axis of symmetry. So the vertex would be at negative b over 2a. And then the y value would be f of negative b over 2a. Now that looks really fancy. All that's saying is that once you find the axis of symmetry, you plug that x value into the function to find the corresponding y value. But this is our new information today that goes with this form of the equation. Okay, this a is the same as that a. If a is positive, it opens up. If a is negative, it opens down. All right, so we're going to take a look now at some problems using those pieces of information. F of x equals x squared plus 4x plus 5. So it is in that form, y equals ax squared plus bx plus c. We are going to determine the axis of symmetry and the vertex. We're not going to graph it yet. We're just going to find the axis of symmetry and the vertex. And then does the graph open upward or downward? Okay, so it's in standard form. A is 1, B is 4, and C is 5. The axis of symmetry is at x equals negative b over 2a, which would be negative 4 over 2 times 1, which ultimately is negative 2. So the axis of symmetry is at x equals negative 2. Okay, any questions yet about how I found the axis of symmetry? So that means if we were graphing this thing, the axis of symmetry would be over here at x equals negative 2. Then we're supposed to find the vertex. The vertex is at negative 2, comma. How do you find the corresponding y value? You take this x value and you put it in there. So you find f of negative 2. Just like back here, if we've got the x value, you find f of the x value. Okay, so we've got f of negative 2 equals negative 2 squared plus 4 times negative 2 plus 5, which is 4 minus 8 plus 5, which is 1. So the vertex is at negative 2, 1, right there. Okay. Now, does this thing open upward or downward? A is positive, so it's going to open upward. So opens upwards. All right. So we can find the same information when it's in this form, but we have to use this and then plug that x value in to find y. Any questions about this problem? All right, let's take a look at another one. F of x equals negative x squared plus 6x minus 15. It is in the form of y equals ax squared plus bx plus c. A is negative 1, b is 6, and c is negative 15. A is negative 1, c is negative 15. Okay. So x equals negative b over 2a would be negative 6 over 2 times negative 1, which is 3. So the axis of symmetry is at x equals 3. The vertex is at 3, comma, f of 3. Now, we've got to be careful with this situation right here. The negative sign is not included in the squaring. It's outside of it. The base is just the x. So I'm going to get 3 squared, which is 9, but then it's negative, plus 18 minus 15. Oh, let's see. That's going to be not what, negative 6, negative 24 plus 18. So the vertex is at 3, -6. And does this thing open upward or downward? It opens downwards. Okay. So if we were going to graph this thing, let's see, 1, 2, 3, we'd have our axis of symmetry over at 3, 1, 2, 3, 4, 5, 6. The vertex would be here, and this thing opens downward. Now, I'm not implying that that's an acceptable graph. I'm just saying that gives you a rough idea of what's going to be happening. Okay. Any questions on that one? All right. Let's see here. F of x equals -x² plus 4x minus 5. It says use the vertex formula to find the vertex of the graph of each function. So all we're going to do here is just find the vertex. Okay. Now, basically, we have to find the axis of symmetry anyway, because that's the x value of the vertex. So the directions are slightly different, but it's really the same thing. So we've got A is -1, B is 4, C is -5, x equals -b over 2a, which is -4 over 2 times -1, which is -4 over -2, which is 2. Okay. F of 2 is -2 squared plus 4 times 2 minus 5, which is, let's see here, -4 plus 8 minus 5 is -1. So the vertex is at 2, -1. Now, the axis of symmetry would have been at x equals 2, and this thing opens downward. All they specifically asked for was the vertex, but all of that's there for the taking. Okay, now let's go back to linear equations for a moment. Let's say you've got an equation, 2x plus 3y equals 12. How do you find an x-intercept of a linear equation? Does anybody remember?
Wouldn't you make y 0?
Absolutely. Good job. How do you find the y-intercept of a linear equation?
It'd be just the opposite, make x 0.
Bingo. Good job, Roger, or whatever name you're using today. Okay. Same idea with second degree equations. Let's say we've got f of x equals x squared minus 2x minus 35. All right. We're going to find the x and the y-intercepts. Well, first of all, what I'm going to do, I'm going to rewrite this. Instead of f of x, I'm going to use y equals x squared minus 2x minus 35. Okay? So we're going to make a table. We're going to find the x-intercept and the y-intercept. So to find the x-intercept, set y equal to 0. To find the y-intercept, set x equal to 0, just like you said. Okay? So if y is 0, what does this give us? It gives us 0 equals x squared minus 2x minus 35. So what have we learned in this chapter that we can use to solve that equation in that form? I sang a little song about it. The quadratic formula.
It'd be -b plus or minus the square root of b squared plus 4ac.
Minus 4ac.
Minus 4ac all over 2.
2a.
2a.
Yeah. But the point is, it's the quadratic formula. So the quadratic formula helps us find the x-intercepts of the parabolas. So let's see, we've got A is 1, B is -2, and C is -35. Okay, so x equals -b plus or minus the square root of b squared minus 4ac all over 2a. X equals 2 plus or minus the square root of 4 plus, let's see, is that 140 all over 2? X equals 2 plus or minus the square root of, oh, I wrote 144, but I said 140. I was thinking ahead. That's not a good thing. 144 over 2. X equals 2 plus or minus the square root of 144 is 12 all over 2. So let's see. X equals 2 plus 12 over 2, which is 14 over 2, which is 7. X equals 2 minus 12 over 2, which is -10 over 2, which is -5. Oh, so we actually have two x-intercepts, okay? We have, let's see, 7, 0 and -5, 0. So those are the x-intercepts. All right. Now, how do you find a y-intercept? You set x equal to 0. Look at this equation. If x is 0, what does this term become?
The 0 squared,
Which is,
0.
what would this term become?
It'd be 0 as well.
So what's left? C.
Just, okay.
So when it's in this form, ax squared plus bx plus c, c is going to be the y-intercept. So we use the quadratic formula to find the x-intercepts. And if you let x equal 0, the first two terms are going to disappear. So that c value is going to be the y-intercept. Okay, so this graph has two x-intercepts and one y-intercept. All righty. Let's see here. Okay. Now, this is another case of where graphing in WebAssign, you only need the vertex and one additional point. If you were graphing not in WebAssign, just using graph paper and everything, you might be asked to find the vertex, the x-intercepts, the y-intercepts, and all of that information. What I want to do, let's see, give me just a second here. Okay. Let's see. Let's do, yeah, let's do that one. So we're going to take a look at problem number 7. This is in your upcoming assignment, and it says find the x and y-intercepts of the graph of the quadratic function. Okay, f of x equals x squared minus 2x minus 63. Okay, so I'm going to set it equal to 0. Okay, y equals 0. That will give me the x-intercepts. Remember, f of x is another name for y. Okay, so let's see here. A is 1, b is -2, and c is -63. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So x equals 2 plus or minus the square root of 4 plus, let's see, 63 times 4 is 252 all over 2. X equals 2 plus or minus the square root of 256 all over 2. X equals 2 plus or minus, and the square root of 256 is 16 all over 2. So X is 2 plus 16 over 2, which is 18 over 2, which is 9. X is 2 minus 16 over 2, which is negative 14 over 2, which is negative 7. So the X-intercepts are at 9, 0, negative 7, 0. All right. The Y-intercept would be at 0, wait for it, negative 63. Okay, because so your X-intercepts, let's see, smaller values, so that would be the negative 7, space 0, and then the larger value would be 9, 0, and the Y-intercept is at 0, negative 63. Okay. Here's hoping it's right. If it's wrong, I'm going back to bed. Okay. So again, when X is 0, this goes away, and all that's left is C, as in AX squared plus BX plus C. So you set Y equal to 0, use the quadratic formula to get the X-intercepts. Set X equal to 0 to get the Y-intercept. Okay? All right. What I want to do now is look at an application problem. So, all right. So are we back to my white screen here? Somebody tell me. Can we see the white screen?
Yes.
Okay, thank you. Just wanted to make sure. Okay. This says fireworks. And I will read this through several times because it's not something you can see on the screen. A fireworks shell is shot up with an initial velocity of 120 feet per second. Its height, s, in feet after t seconds is approximated by the equation s equals 120t minus 16t squared. So t stands for time in seconds, s stands for height in feet above the ground. All right. If the shell is designed to explode when it reaches its maximum height, how long after being fired, and at what height will the fireworks appear in the sky? Okay. First of all, let's take this thing and let's put it in standard form. So there's ax squared plus bx plus c. In this case, c is 0. All right. If we were to take the time to graph this thing accurately, since a is negative, it opens downward, okay? When t is 0, s is 0, so it goes through the origin. So the graph is going to look something like this, roughly speaking, okay? Now, we want to know, let's see, where did it go again? After how long after being fired and at what height will the fireworks appear in the sky? This is t, which is time. This is s, which is height. So basically, we're looking for the vertex. The vertex is the highest point on the graph. It would have the maximum height. So that would give us the maximum height that it's asking for. T, time, would be the input value of that vertex, that would tell us at what time it reaches the maximum height. So basically the vertexes of the form t comma s, t is the time it reaches the maximum height, s is the maximum height, okay? So we need to find the vertex, all right? We're going to use x equals negative b over 2a. And we've got a is negative 16 and b is 120. We don't need c, but c is 0. So we've got negative 120 over 2 times negative 16, which is negative 120 over negative 32. Negative divided by negative is positive, and 120 divided by 32 is 3.75. So what is that? That's the time at which it reaches its maximum height. Okay, so how long after being fired? After 3.75 seconds. What is that maximum height? Well, that would be the y value of the vertex. So what are we going to do? We're going to take this and put it in here and here. So the height is going to be negative 16 times 3.75 squared plus 120 times 3.75. Okay. So on the calculator, negative 16 times the quantity 3.75 squared plus 120 times 3.75, and I'm getting 225. So the height is 225 feet. So what that means is 3.75 seconds after that firework is launched, it will reach a maximum height of 225 feet, and that's when it's set to go off for the maximum effect. Okay? Any questions about that? All right, I want to do one more application problem. It says, suppose you are a police patrol officer and you have a 300-foot-long roll of yellow do not cross barricade tape. Okay, so oops, that doesn't work very well. Well, I was going to try and be clever and use yellow. So we've got 300 feet of tape. Okay. To barricade and seal off an automobile accident as shown in the illustration. All right. And what you can't see is that they're making a rectangle. And inside that rectangle are these two cars that had this accident. Okay. All right. I know that's why I don't teach art. Okay. What dimension should you use to seal off the maximum rectangular area around the collision? What is the maximum area? All right, so we've got 300 feet of tape to go all the way around this thing. All right. Would it be safe to say that because this is a rectangle, if we just considered these two pieces right here, those would have to add up to half of 300, which would be 150? Okay. The whole thing's 300, so half is 150. All right, let's call this side x. This side would be 150 minus x. Now, do you understand where I got the 150 minus x? Anybody? Is that a no, or is that a just keep going on? All right, I guess I'll just keep going on then. So the area is the length times the width. The area would be 150 minus x times x. The area would be 150x minus x squared. And if we put that in standard form, we get that. So there's the function, or the equation that describes the area of this rectangle. Okay. In fact, I'm even going to write it as a function. A of x equals negative x squared plus 150x. But what do I want to know? It says, what dimension should be used and what is the maximum area? Okay, so let's take that equation or that function, a of x equals negative x squared plus 150x. All right. If I were to graph that thing, again, it would be a parabola that would open downward. This would be x, which is one of the distances, and this would be a of x, which is the area. So the maximum area is the maximum value of the parabola is the y value of the vertex. And the corresponding x value would be the distance involving x. So let's see here. A is -1, b is 150, x equals negative b over 2a, negative 150 over 2 times -1, negative 150 over -2 is 75. So x is 75 feet. What's 150 minus 75? Well, that's also 75 feet. So in fact, this rectangle is a square. That's still a rectangle, but it's a square. All right. So the dimensions would be 75 feet by 75 feet. Now, what is the maximum area? Well, that would be a of 75. And when we punch that in to calculate it, let's see here, -5 squared plus 150 times 75. And we get 5,625 square feet. So maximum area 5,625 square feet. So the last couple of problems, the answers were in the vertex of the parabola. But make sure you get the right value of the vertex for the right question. A common mistake is people will find a vertex, but then they'll give the wrong number for the wrong question, okay? All right, well, are you still alive? Apparently not. Apparently, oh, Roger's there, okay. Earlier I asked if people understood and nobody answered, so I just kept going. Anyway, I'm gonna stop.